Okay, so I want to tell you a short story about a small company I visited in 2015. They were called The Pulse, and they were trying to convince me to have my company adopt their new SaaS product, which was a project management software. And when I entered the small offices, the one thing that's two things basically struck me immediately. One thing was the abundance of retro gaming arcade machines, but the other one was screens. Screens were everywhere, and I'm talking about big screens on the walls. There were more screens than people, actually. And I asked my host, what is this? Why do you have so many screens? This is basically what was on those screens. It was a dashboard with a lot of numbers, and he told us, listen, we call this big brain, this is our philosophy. We are going to do everything driven by data, and all the growth and marketing decisions are going to be driven by data, and that's how we're going to win. And then I noticed something within this dashboard which took curious to me, and I asked them, what is this Boris thing? One of the drafts said Boris percentage. And he said, well, Boris is the name of the algorithm that Boris built that basically predicts how many users will convert from an existing paid marketing cohort. And we use that prediction, we look at it every hour, all the time, and make decisions to move budgets and change bids on our campaign. So this was very inspiring to me. And at that point, I didn't know it yet, but 9 years later, that company rebranded to Monday.com, one of the most successful Israeli companies. They're at the 12 billion market cap valuation, publicly traded. And they did this by using AI-driven marketing everywhere across their growth stack. Coincidentally, the biggest competitor and the dominant player in the market at that point, back in 2015, were Asana. And today Asana is valued at 2.6 billion. So it worked for Monday, and that inspired me. So that was a short story. That is basically the background to what I'm doing today. I'm Eran Freninger. I'm the co-founder and CTO of Voyantis. Voyantis is an Israeli company. We have offices in the US as well. We raised $30 million, founded 4 years ago, and our main partners are Meta, Google, and TikTok. You can see a few of our customers and our brands here. I'm not going to talk about them too much today. I'm going to talk about the process of using predictive LTV to optimize your marketing spend, but towards the end, we will focus on a couple of more relevant customers such as Moneyline and Honeybook within the fintech industry. Okay, so basically AI has leveled the playing field. So targeting obsolescence basically means that networks just tell you stop trying to use exact targeting to get basically an edge over your competitors, because the AI is doing it much better. They favor bot targeting, and this is no longer a tool that top brands can use to get better results than their competitors. Same thing goes to automated bidding. So we no longer do we need to do manual bidding. We actually cannot really do it very effectively anymore because the AI again does it much better on the network side. So advertising are losing control, and bidding is being taken over by the networks and actually driving better results just for everybody, right? And the last thing is that we now get limited insights because automation means we don't understand as well what's happening behind the scenes, and it's harder for us to get that visibility into more granular segments. So all of these levers have basically been democratized to everybody, which is generally a good thing. But how do you stand out as a brand, right? How do you get your performance marketing to be extra better than your competitors? So have we lost control? No, we still have levers, but these are different ones. So the most obvious one would be the creatives. A creative means an audience, equals an audience, right? So the more creatives we have and the more creatives we test, we can reach more micro segments and have better granularity in who we are getting into a funnel. And generative AI is basically the technology, the machine learning technology that is driving this with the ability to generate thousands of variations and test a lot of creatives. However, another lever that we have is signals. What we're sending is feedback to the network for their smart bidding and automated bidding algorithms. And the better data we pass back there, the better we tell the network how much each customer is valuable to our specific business, the better they can stratify user value and do basically, I would say, a gradual or relative bidding and drive much better performance. The technology to do that is not generative AI, although generative AI is getting most of the press today. It's actually predictive AI and prescriptive AI, which are more the, I would say, classical of the last 10 years deep learning and machine learning techniques. So today we're going to focus on the signals part. So let's look at how can we use predictive signals to improve performance. So basically, you need to look at how we run a campaign and how the bidding works behind the scenes. So we start by setting up a campaign and setting up an audience. Again, it's going to be a very broad audience. Maybe we limit some geos and so on. And then we set other campaign attributes, optimization goal, conversion window, and so on. And then let's look at an example funnel. Okay, in this case, I'm going to look at a payday loan or cash advance solution. So a typical funnel would be visit the website, fill a KYC questionnaire, open up an account, and then maybe deposit your salary, get a cash advance, or maybe open a savings account, maybe take a loan, maybe take another cash advance, pay back the advance, and so on. So within the first 7 days, which are the maximum conversion window, we only have open an account as the deepest funnel event. So most marketers will then set their campaigns to a smart bidding of highest volume on open account, and that would then send the network to the list of users that are potentially going to get an impression, and the network would estimate the probability of each of those users to actually open an account. It would rank them according to that list, and it would bid on them according to that ranked probability. And that is great, but the actual value of users in this case would take several months to demonstrate itself, right? And the money is made out of fees from those services later on. So what do? If we could, by some, have a magic ball or some kind of a magic solution where we could actually predict the lifetime value early on within the first day, so know on day one what the lifetime value will be, then we can basically switch to target ROAS or maximum or highest value bidding strategies, which will get the network to then rank the users not by their probability to open an account, but by the average expected revenue, or average revenue per user. And that is the real value of those users to your business, and that's how you want the network to bid on that. So if we were to be able to create this prediction, and it would have been accurate enough, we can achieve this. This is what we're going to try and do, or this is what you want maybe to try and do. So we need predictions, right? That's one thing that we need. However, we actually need 3 things here to make this work, to actually get the business impact. The first one is the most intuitive one. We need to build a model, and we need that model to forecast the value of the user. But actually, we don't need to build one model. We actually need to build several models, and I'll get into that later on. But philosophically, we build a model. But then we want to take that model and turn it into actions within the network, and simply sending those predictions over to the conversions API to copy is not enough. You basically need to somehow translate, and I'll elaborate later, those predictions to Meta, and we call that translation the orchestration layer. So tell the ad network how to get there. And then the third layer is to make sure that this keeps working, because once you've got the uplift that you want and you've got better performance, you still need to make sure that your models are up and running, that they're not drifting, and that everything is working, and that you have an incident response team that catches issues and solves them, so the campaign doesn't go haywire. All of those 3 levels together, 3 layers, would basically allow you to unlock growth. So we will go into each one of them. Just to illustrate, I want to explain that getting there is not just a matter of building things. This is basically a process that would require time, resources, and dedication to get an organization to switch and shift from optimizing on volume to optimizing on quality. It will take time and money, as I said, and when say time, best case will be a few months, 3 to 6 months. Usually it can take up to a year, unless you've already done this before and have the experience. So there are a lot of steps. First step is because this is so resources and time heavy, you need to get executive sponsorship. If you don't get executive sponsorship, this project will just fail somewhere along the way. And then you need to make sure your data is organized and captured. If you're lucky, it's already there. And then you need to set the target goals and KPIs. What are we trying to achieve? Is it actual 6-month revenue? Are we trying to lower the cost of paying customers? Are we trying to increase their gross or net margin and so on? Once that's decided and aligned on within the organization, train the model on those goals, vet the model, evaluate the quality of the model on those goals, and then decide how to translate the model predictions with the orchestration towards the network. At this point, you've done a lot of work, and it's time to stop and check in with your executive sponsor that you actually secured the budgets and the time to achieve your goals, and that what does good look like is agreed across the organization. Then you can deploy the model to copy and start training the network. You then need to QA the conversions and match rate and net keys and so on. Then you need to strap on your helmets because it's about to get rocky. You run on an A/B test that can take a few weeks, can go up to a couple of months. Conclude the test, then you need a rollout plan because, as you know, we just tested something. Now we want to have it across all of the account, and this needs to be gradual because we don't want to rock the boat. Once we got there, maintenance starts, and that's not an easy thing to maintain machine learning in production. So it's a long roadmap. And so let's talk about the building of the model. Specifically for fintech, as has been stated by Tor and others before in this talk, there's a lot of advantages because you've got a lot of extra data from other industries. Basically, the KYC is a super relevant advantage. The deposits, the connection of bank accounts, of credit cards, and so on, the transactions themselves, issuing any credit card, so on, and also the qualifications that you have on customers on the risk. All of that is information that is extra from other industries and is very valuable. All of the data usually sits within the relevant data lake or data warehouse. And then you have the regular data that any company should use to deploy a model, even if they're not a fintech company. That would be the engagement data, the visits, the email interaction, the features used, specific features of the product used within the user journey, any kind of attributes of the user device, user agent, and so on, and just general session length and time series analysis. All of that can go to inform the model so it can create better predictions. You then need to apply a bunch of machine learning and algorithmic tools. We don't need to go into all of them, but it goes into feature engineering and time series analysis and ensemble and deep learning and so on. So get your data science or data analyst to work on that. And once you've got the model, are we ready? No, because predictions are not enough, as we said, but it's definitely a very big first step forward. So I said that we're not building a model, we're building models, plural, right? And the reason is that think about a user and their journey within the product. At moment zero, basically, you don't know a lot about the engagement of the user, but you get some attributes and some KYC. That's it, right? So you can create a prediction. But 1 hour or 2 hours later, you can also see what they did within the product, and so on. So basically, you can update the prediction of the user as data about that user keeps going on. Within the first 7 days, when we are within the attribution window, it is worthwhile to keep updating frequently the prediction of the user as data flows in. This would be the red dots here in the acquisition phase. Once we're outside of the attribution window, it can still be valuable to update the predictions, mostly for your BI and for cohort analysis and financial forecasting, but there's no need to do it as frequently. We're going to focus on the red side, on the red dots, and the updates. This means that each user has a stream of predictions. What do we do with the stream of predictions? Okay, so basically, how does predictive and prescriptive AI work together, and actually, what are they? So, predictive AI is basically when you just try to predict what will happen if everything keeps going without us interfering. So, you can predict what the user will be worth, right? That's exactly what we just discussed, the lifetime value of an existing user. That can help you forecast costs, that can help you make better budget and bid decision on your campaigns and ad groups and ad sets and so on. But it does not affect what happens, right? It will just affect the budgets. Prescriptive AI is basically an opinionated version of the predictive AI that is actually trying to change the reality of what's going to happen. In this case, prescriptive AI might means that you want to try to get Meta to get you better traffic. Now, meta bidding strategies are not just an algorithm. They're not just a bunch of simple algorithms. They are products. They are complex products with quirks and traits and engineering trade-offs. Just as an example, yes, there's conversion window is 7 days, but if you send a conversion after 1 day or after 6 days, the weight of that conversion in the algorithm decision is not the same. Right? How do you deal with that? That's just one example. You need to know how to speak the language of the product on the other side. It's a technical language. And you need a way to transform the stream of predictions, the red dots that we've just seen, into the right conversion events to send over to Meta, to get them to do what you want. So again, first 7 days, algorithms are very hungry for an abundance of signals. You need at least 50 conversions per week. That's the recommended number. And earlier rather than later within that window is preferable. So let's talk about some of those transformations. I'm just going to touch a couple of them. There's a lot of business logic needed here to make Meta do exactly what you want. But let's talk about accuracy this time. Let's say we have a user come in, they start using the product, and it's been 1 hour since they registered. At this point, the algorithm says the prediction is $500. The accuracy, the amount of things it has, is $50 for this specific user at this specific point in time. If we were to wait 3 days, for example, the prediction will update to $400 in this example, and the accuracy would go up to 95%. So if I could, I would have done an interactive session with you and asked you what do you think we should do, but it's a little hard in this format, so I will just tell you what the answers I usually hear are. So most people will tell me scenario 2 is preferable. The accuracy is so much higher that you should wait 3 days. And that's probably correct, although again, the weight of the conversion sent after 3 days is much lower than the one after 1 hour on the algorithm on the other side. However, remember that in scenario 1, we don't yet know what's going to happen in scenario 2. It's been 1 hour, and you need to make a decision right now. Do I send the $500 or do I wait? So you basically need a meta algorithm, if you excuse the pun, that looks all over the PLTV prediction and predicts how much will accuracy increase if I wait 1 more day, 2 more days, and so on, and then make a decision on top of that. And the answer to that question can be different between different users within the same campaign. And it actually also needs context. How many signals have already been sent? How long has this campaign been going on? Is it already out of learning? And so on. So that's one example. Another example would be the weight of whales and extreme generally. So let's say the prediction is usually, or the value is usually between $10 to $200. Some users will be worth almost nothing. Some users will be worth a lot more. The whales, right? In this example, I put $5,000. So if somebody actually is worth $5,000, should we send that large of a number back as a conversion value to Meta? Intuition says yes, but practicality says no. One single user overshadowing the whole conversion value of the campaign can just throw the network off for a very long while. So what should we do? Should we exclude that user? We could, but it does hold very valuable information. What we found that works well is basically to kind of curb this, kind of cap the value of whales when you're delivering back to the network. This is in contrast to what you would do if you're using those predictions for your BI to forecast financial performance. You should not cap when you're forecasting financial performance. But for the network, you should cap. I would probably cap this at $1,000 or something like that, depending on the distribution of data. So there are other business rules and business logic rules, but I'm not going to go into too deep into that. So we talked about two levels. We talked about the prediction and we talked about the orchestration and basically translating to the language of the product we're trying to affect. The third level is around quality and monitoring and incident response. The one truth we all know when we're dealing with data, that it will break. Data always breaks, right? So this is why I said helmets on before that. When you think about it, men invented the helmet only after men invented basically the bicycle. When we walked around in the forest, we didn't need a helmet. But once we started riding a bicycle, and definitely a motorcycle, we needed a helmet. This is very similar to what we're doing here. As long as we've been using our BI data and our data lake to just basically create BI views and inform marketing decisions, then if we know that the BI broke or a specific table is malformed, we can just wait until it is solved. The campaign will keep working and we can use the ads manager to generally make sure that everything keeps running smoothly. The moment data informs a model that informs the bidding mechanism, automatically breaking data will break the campaign. Not immediately, but automatically. So you've got about, I would say, 1 to 2 days tops to fix this, right? So what can go wrong? A lot of things can go wrong. Models can drift, match rates can drop, data can break, data can be corrupted, tables can come in with higher latency, or black swans such as COVID or whatever can really interrupt the way consumers interact with the product and with the ad networks. So the first thing is to have 24/7, 365 monitoring and response, detect that there is an issue, deploy some kind of fallback or solution, interim solution, because the underlying problem might take time to solve. If a data table is broken, it will take time to solve it. So we need an immediate solution. And if we need, once we have the immediate solution, we can also retrain at our leisure because we have an immediate solution. That loop has to be there all of the time. That is the helmet. And that helmet takes a lot of resources to provide, but it's worth it because of the super strong uplift you can get if you actually put all of this in place. And we'll talk about that uplift. Okay, so again, just to recap, build a model, build the orchestration layer to tell the network how to get there, and then quality monitoring and incident response to make sure it keeps working, and you've unlocked significant growth. Let's talk about a couple of real-life examples, and then we'll wrap it up. So the first one is Honeybook. Honeybook is a fintech company, business management service, where you can manage your customers and your vendors and make vendor payments and so on. They were interested in high-value customers, getting VIP users, basically high LTV. And their challenge was that their funnel looks like a sign up for a free trial for 7 days and then a subscription. And after that, over time, you can make payments to your vendors, and they're basically making most of their money from the fees on the payment and not on the subscription. Problem is, only 2% of the users that would eventually use the payment service do so within the first 30 days. They just cannot optimize on that element. So what are they doing? They're optimizing on a free trial to sign up. And they asked us to help them, and we worked together and built this following system, integrated into our product, which is this following system. We connected their data lake, gather all of their first-party data, performance data, declarative KYC data, and engagement data, feed that into the predictive engine. The predictive engine then creates 3 outputs. One is the predictive AI, which can go to your BI and help you, again, see visibility into forecasting and so on, and the monitoring AI that makes sure that there's no issues, and if there are, it deploys a fallback. In addition to that, the prescriptive AI feeds the networks, both Meta and Google in this case. We're going to discuss the results on Meta today. And they ran an A/B test with us. The control group was just highest volume on a start free trial event, and the experiment group was value optimization on probability to convert into an activated vendor paying user. We ran the experiment for 8 weeks on all of the US traffic, and the results were amazing. 100% increase in ROAS, 50% decrease in CAC, and so on. I won't go into all of the details, but I would say that the vast majority of the spend today is deployed on their predictive signals because it's performing so much better, and not just in Meta, but in other networks as well. So that's Honeybook. Moneyline is basically that cash advance solution that I talked about in the beginning. Basically, they are a cash advance. The product is InstaCash. You can get a cash advance, and they were looking for lifetime value, high lifetime value customers, basically, and there is an extensive time lapse between the first 7 days and that value. Again, the funnel is downloading the app, opening, connecting your first financial account, and then making a cash advance request, paying it back, doing it again, paying it back, doing it again, and so on. So a high value customer is a user that will take several cash advances over time, and they make the money. Actually, they're not even, you don't even pay a fee. It's a voluntary fee. It's tips or fees for a turbo cash advance, which is a very interesting model. And basically, the business as usual go-to strategy was to run highest volume on the first financial account opened. So they wanted to switch to RAS-based optimization, very similar setting to Honeybook. The old goal was cut for InstaCash first financial account sign up. The new goal was predicted LTV, and the results are very good. I cannot share exact numbers as they are a publicly traded company, but this is a quote for them. They wanted to get at least a 10% increase in RAS. They would have been happy with a 30% improvement, and we surpassed that expectation. So high double-digit uplift, and again over there as well, deploy the most of the traffic with that predictive signal. So those are two examples from real life, and let's talk about